Okay, so this will probably be the last video that I make today, and then either on Tuesday or Wednesday I will make the videos where we're actually going to do some numerical differentiation, numerical integration, and then look at the NumPy and the SymPy and the Matplotlib packages. Okay. So again, my goal is I want to create this cell in such a way that when I run this cell here, so that 255 is loaded into the in variable, I just run this, and it's going to give me all of the list of the numbers in the Collatz sequence for whatever number this is. So I'm going to go back to 15 since that's what we started with. So I want to do, just run this once, and it's going to give me the list of all of the numbers that I have. So I don't have to keep doing this over and over again, and I'll also get a list of all of the numbers. Okay. So I'm going to use a while loop. So I'm going to say the following. So I want to do this. So this is an iterative process. I'm going to start with n is equal to 15. I'm going to apply this Collatz function to it. And I want to do this Collatz function to this number over and over again until that's equal to 1. So in other words, I want to use a while statement. I want to say while n is greater than 1. Okay, now I could do a number of things. I know all of my numbers are going to be positive. It's never going to be negative because there's nothing that would cause this to go below 0. I'm only doing things that if you start with a positive number, you get a positive number back. And I only have integers. So I could say while n is greater than 1, do something. And as soon as n is equal to 1, it's going to stop doing this loop. Okay, or I could say while n does not equal to 1. So this means do something while n is equal to 1. If I do this, it means do something while n is not equal to 1. So either one for this problem will have the same result, though obviously they're different things, right? This is while n is not equal to 1. This is while n is greater than 1. You can do whichever one you want. Now, I want this code to be executed. I'm going to get rid of this for now. I want this block of cell to be executed for each value of n. So I'm going to tab all of this over. So everything has to be tabbed one tab over. So now I'm going to have this. So now what's going to happen, let me get rid of this. So now what's going to happen, n is equal to 15. When I execute this code, it says, okay, is n greater than 1? Yes, 15 is greater than 1. Now it's going to go down to this body of code. So now what is n? N is 15. If 15% 2 is equal to 0, we're going to do one thing. 15, the remainder of 15 divided by 2 is 1, so it's going to go to this line. So now n is going to be equal to 3 times n plus 1. So n is currently 15, so 3 times 15 is 45. We add 1, and so now the new value of n is going to be equal to 46. Is going to go back up to the top of this loop while 46, okay, while n is greater than 1. Is 46 greater than 1? Yes, it's going to do this over and over again. And so now, when I run this code, in Jupyter's mind, n is equal to 15. Now I'm going to run this code, and for every loop, it's going to change the value of n, and it's going to print out what the corresponding number is in the Collatz sequence. So I'm going to run this, and there we go. It's going to give me all of these. Okay, now let's say I wanted to do it with n is equal to 100. So now I need to run this line of code so that in Jupyter's mind, n is equal to 100. And then when I run this line of code, it's going to give me all of this stuff right here. Okay, so this is the Collatz sequence for 100. If we do 1,000, it's probably going to be much longer. You can see there it's much longer. Okay, so let's go back to 100. And let's say now, in addition to knowing the sequence, let's say we want to know the number of terms in the sequence, like how many steps it takes us to go to 0. So I'm going to introduce a new variable, counter equals 0. And in each step of the loop, I'm going to increment counter. So counter equals counter plus 1. And I'm going to print at the end of it, I'm going to print the counter. This is going to give us the number of elements in this sequence here. So when I run this, So n was equal to 1 when I ran that. So I need to reset it. This is one of the bad practices that Jupyter Notebooks can create. Anyways, I should maybe say here, there are elements in the sequence. Okay, so now if I run this again, in Jupyter's mind, n is equal to 1. So if I run this again, you'll see what we get. Okay, nothing, right? Okay, so I need to run this again and then run this again. There are 25 elements in the sequence. If I go back to 15 and run this and then run this. Also, when we have functions, it'll make some of this a little bit easier to deal with as well. Okay, when we learn about functions, we'll be able to do this just by running one cell of code instead of having to run 2 cells of code. But for now, this is what a while loop does for us. This is an example of a while loop. So that's it for today. I might make another video today where I look at computing a numerical derivative, but I don't know if that's what I'm going to get to today.